Hello everyone. In this video, we are going to learn about the tangent line to the graph of a function at a point. So here, we will be illustrating the tangent line to the graph of a function at a given point. So we will learn how to construct the tangent line of a certain function at a given point. We will also try to solve some problems in finding the equation of that tangent line. But before that, let us recall what you know about tangent lines. I believe na naturuan tayo sa ating previous math classes na ang tangent line is a line that intersects a circle at exactly one point. Tama? And suppose we have this circle and this point here. So most probably, yung tangent line natin will look like this one, right? So this line here is our tangent line. And this point is what we call the point of tangency. Okay? Now, madali lang mag-construct ng tangent line if yung given na curve ay circle. Now, what if we will consider another curve? What if we have a line? What will be the tangent line of this line at this point here? What if we have this curve? Ano ngayon yung tangent line niya at this point here? So in that case, mahihirapan tayong mag-construct ng tangent line kasi yung alam natin na tangent line is for circles only. Okay, and we will learn that one here in our lesson. How are we going to construct the tangent line of a certain curve aside from circles? Okay, and here we will be dealing with functions. Okay? So para masagot natin yung mga questions na yon, let's consider this definition. Let C be the graph of a continuous function y equal to f of x, and let P be a point on C. For illustration, suppose this is our xy plane. This is our curve y equal to f of x, and suppose this is our point P. The question is, what will be the tangent line of this curve at this point P? Okay? So to answer that one, this will be our tangent line. Ngayon, papaano ba to nangyari? How are we going to construct this tangent line? Because we can have a lot of lines na mag-i-intersect to this curve at point P. We can have this line here, right? But that line is not a tangent line. So, hindi yun pwede. Itong blue line lang yung tangent line. So, the question is, papaano ba natin ito makakonstruct? Okay, so to help us construct this tangent line, let's consider this point Q. Now, if I'm going to connect point Q and point P, I will have another line. This line is what we call a secant line. A secant line to y equal to f of x through point P is any line connecting P and another point Q on C. So if you are going to connect 2 points on the curve, ang tawag doon ay secant line. So papaano ba makakatulong itong secant line sa pagko-construct ng ating tangent line? Now, what if I'm going to move this point Q closer to point P? Like this one. Suppose ito yung bago nating point. In that case, we will have another secant line. So as you can see, mas malapit na yung form niya sa tangent line natin kesa sa naunang secant line. Right? And if I'm going to move this point much closer to point P, like this one, I will have another secant line na mas malapit yung form kaysa sa naunang dalawang secant line. And if I'm going to move again this point much closer talaga kay point P, I will have another line that is almost the same na ng form ng ating tangent line. So therefore, from that illustration, para makuha natin itong tangent line, ang gagawin lang natin ay i-move lang natin yung point Q sa point P. Okay, so if we are going to move point Q much closer to point P, we will have a glimpse of our tangent line. So therefore, itong tangent line will limit all the secant lines na mapo-form natin. So in that case, itong tangent line pala is the limiting position of all secant lines. So this will be the definition now of our tangent line. So the tangent line to y equal to f of x at point P is the limiting position of all secant lines PQ as Q approaches P. So in that case, since we have here from the definition, it is the limiting position. From that word, we can now apply the knowledge that we have learned about limits. And since it is the limiting position, makakakuha lang tayo ng tangent line if yung limiting position from the right is the same with the limiting position from the left. Kasi pwede tayong kumuha ng another secant line dito sa left side ng P. And para mag-i-exist yung ating tangent line, since it is the limiting position, dapat yung limiting position ng ating left side ay the same sa limiting position sa right side. And that will be our tangent line. Okay? So this is now the general definition of the tangent line. It will also satisfy the definition of the tangent line sa circles. Just try to imagine if you are going to get, suppose this is our circle, and suppose that we are going to consider this point here. So this is our tangent line, right? If you are going to let or we are going to consider all the secant lines from the left and from the right of this point here, makikita natin na yung mga secant line ay nililimitahan ng ating tangent line here. So therefore, tangent line is really the limiting position of all secant lines. Okay? So this is now the general definition of the tangent line. Now, how are we going to know the equation of this tangent line? To answer that one, let's consider this. Let P with coordinates x sub o, y sub o be a point of the graph of y equal to f of x, and Q with coordinates xy be any other point on the curve. So therefore, point P here has the coordinates x sub o, y sub o. So since x sub o, y sub o yung ating coordinates dito sa x axis natin, this will be x sub o. And sa y-axis natin, we have y sub o. Tama? And since Q has the coordinates xy, so dito sa baba will be x. And dito sa taas will be y. Okay? So there. Okay. Now, to know the equation of this tangent line, one way is using the point-slope form. The point-slope form is given by y minus y sub 1 equal to m times x minus x sub 1. Here, m is the slope of the line, and x sub 1, y sub 1 is the point, okay, on the tangent line. So in this case, that is point P here, right? So that is the point on the tangent line. So malalaman natin yung equation ng tangent line if we will know the slope of this tangent line and the point P. So in this case, binigay na yung coordinates ng ating point P, which is x sub o, y sub o. So the problem now is the slope of this tangent line. Now take note, slope is just rise over run, right? Slope is equal to rise over run, or that is just the change in y over the change in x. And we can only solve that one if we have 2 points on the line. In this case, sa ating tangent line, isa lang yung alam natin. But take note that tangent line is the limiting position of all secant lines. And sa secant lines, we have 2 points. In this case, we have point P and point Q, right? So therefore, from that, we can solve for the slope of the secant line PQ, right? So let's try to solve the slope of the secant line PQ. So we will have the slope of the secant line. So let's denote that one as M sub SL. And that is equal to delta Y over delta X. So delta Y is the distance from, or the distance of the 2 points. So in this case, we have point Y and Y sub O. So the distance here is delta Y. And to solve that one, we will just subtract the two values. So para makakuha tayo ng positive na value, we will have Y minus Y sub O, right? And delta X is the distance of the 2 points here sa baba. So this is delta X. Since we have Y and Y sub O, so we will have X and X sub O. So we have over X minus X sub O. So this is now the slope of the secant line. But we need the slope of the tangent line. And take note, tangent line is the limiting position of all secant lines as Q approaches P. So as Q approaches P here, you can see that X will approach X sub O. And since that is limit, so therefore, the slope of the tangent line now is the limit of the slope ng secant line. And that will be Y minus Y sub O all over X minus X sub O. As X approaches X sub O. Kasi si X will approach X sub O. So our C here will be X sub O. So this will be now the formula in finding the slope of the tangent line. That's why we have here the slope of the tangent line TL at point P is the limit of the slopes of the secant lines PQ as X approaches X sub O. In symbols, we have this one. Okay? Now, if your function is in terms of f of x, like this one, you can just change y into f of x. So we will have the limit of um, f of x minus y sub o is just the value of the function at x sub o. So that will be f of x sub o all over x minus x sub o as x approaches x sub o. So they are just the same formulas. Okay? And also, since the tangent line passes through P with coordinates x sub o, y sub o, then its equation is given by this one. So let's erase this one here. Ayon. So this will be our equation. So that will be given by y minus y sub o equal to m sub TL times the quantity x minus x sub o. Saan to galing? That is from the point slope form na formula. So our x sub 1, y sub 1 is x sub o, y sub o. So just replace it with x sub o and y sub o. And our slope m is just m sub TL, the slope of the tangent line. So we will use this formula. Or if your function is given in terms of f of x, so we will have f of x minus f of x sub o equal to m sub TL times the quantity x minus x sub o. So this will be the formula that we are going to use. Okay? Now, para mas maintindihan natin ito, let's consider the following examples. For number 1, find the equation of the tangent line to y equal to x squared as at x sub o equal to 2. So here, binigay na yung curve natin or yung function, and that is y equal to x squared. At binigay rin yung x coordinate ng ating point, and that is x sub o equal to 2. Now, take note, we can only solve for the equation of the tangent line if you are given with the point P or yung x sub o, y sub o natin at yung slope ng tangent line. In this case, yung binigay lang ay yung x coordinate ng point or yung x sub o. So we need to solve first for the value of y sub o. So that will be our first step. Find y sub o. Okay? So to find y sub o, that is just the value of the function at x sub o. So therefore, we will just substitute the value of x sub o, which is 2, to our function. So you substitute 2 to your x here. So we will have y sub o is equal to 2 squared, and that is equal to 4. So ang ginawa lang, we substituted 2 to your x. Okay, so you have 2 squared equal to 4. So therefore, our point P has the coordinates 2 and 4. So 2 is our x sub o, and 4 will be our y sub o. Okay, next we need to solve for the slope of the tangent line. So we will find m sub TL. Now, using the formula, we have m sub TL is equal to the limit of y minus y sub o all over x minus x sub o as x approaches x sub o. So from that, we will have now the limit of, take note, our function, our variable is in terms of x. So therefore, yung mga y dyan, dapat ma-express natin in terms of x. So since y is equal to x squared, so we can replace y with x squared here. Kuha. So therefore, y is will become x squared minus y sub o. We have calculated it, and that is equal to 4 all over x minus x sub o is equal to 2 as x approaches x sub o, which is 2. Now, if we will try to do direct substitution, this will become 2 square, which is 4, minus 4, so you will have 0, over 2 minus 2, that is also 0, which is indeterminate. Whenever we have an indeterminate form, we will apply factoring or rationalizing. In this case, we will apply factoring. So applying factoring, the factors of x squared minus 4 are x plus 2 and x minus 2, right? All over, you have x minus 2 as x approaches 2. Now, you can see here that there is a common factor, and that is x minus 2, so we can cancel that out. So what's left now is the limit of x plus 2 as x approaches 2. And since x plus 2 is already a polynomial function, we can do direct substitution. So we will have 2 plus 2, and that is equal to 4. So we already have the value of the slope ng tangent line. Next is we can now solve for the equation of the tangent line. So find the equation. And we will apply the formula. We have y minus y sub o equal to m sub TL times the quantity x minus x sub o. So we just need to substitute x sub o, y sub o, and m sub TL. And from our calculations, we will have y minus y sub o is 4. And we have m sub TL is also 4 times the quantity x minus x sub o is 2. Now, simplifying, you will have y minus 4 equal to distribute. You will have 4x minus 8. Okay? Now, removing negative 4 sa left side, we will have y equal to 4x minus 8 plus 4. So, the final form will be y equal to 4x minus 4. And this will be the equation of the tangent line. Okay, so this is the answer for problem number 1. Now, let's try another problem. Find the slope-intercept form of the tangent line 2f of x equal to square root of x. So, this is our function at x sub o equal to 4. So, again, ang binigay lang ay yung x-coordinate ng ating point. So, we need to solve first again. So, we will find f of x sub o. Kasi yung function natin is in terms of f of x. So, para may consistency tayo sa notations, So instead of y sub o, we will have f of x sub o. So f of x sub o will be equal to, our x sub o is 4, so we have f of 4. So we will now substitute 4 to x, so that will be square root of 4, and that is equal to 2. So we substituted 4 to x. Okay, therefore, our point has the coordinates 4 and 2. This is x sub o, this is f of x sub o. Okay, next we will solve for the slope of the tangent line, m sub TL. So applying the formula, we will have the limit of f of x minus f of x sub o. So yung y naging f of x at yung y sub o, f of x sub o. All over x minus x sub o. As x approaches x sub o, so from that we will have the limit of f of x is square root of x minus f of x sub o is 2 all over x minus x sub o is 4 as x approaches 4. Now, if we will do direct substitution, we will have square root of 4, that is 2 minus 2, so you have 0. All over 4 minus 4, which is also 0, so indeterminate again. So in that case, we will do rationalizing in this case kasi wala naman tayong mafa-factor dito, right? So we will multiply this expression here by square root of x plus 2. And we will also multiply it to our denominator. So yung ni-rationalize natin ay yung numerator, right? So we will now have the limit of square root of x minus 2 times square root of x plus 2. We will just square the first term minus square of the second term, right? All over. Copy the denominator. You have x minus 4 and square root of x plus 2 as x approaches 4. Now, simplifying, you will have the limit of square root of x square is x minus 2 square is 4. All over, copy the denominator, x minus 4 square root of x plus 2 as x approaches 4. Now, from that, you can see a common factor, and that is x minus 4, so we can cancel it. So, what's left is the limit of 1 over square root of x plus 2 na lang as x approaches 4. And we can do direct substitution here. So we will have 1 over square root of 4 plus 2, and that is equal to 1/4. And that will be the slope of the tangent line. Okay? Now for letter C, we will now find the equation. Okay, so just apply the formula. So you have f of x minus f of x sub o equal to m sub TL times the quantity x minus x sub o. So f of x, it is given here, that is square, f of x minus, so yung isa-substitute lang natin ay si x sub o, f of x sub o, and m sub TL lang. So we have f of x minus, f of x sub o is 2, equal to m sub TL is 1/4, times the quantity x minus x sub o is 4. Then simplifying, you will have f of x minus 2. Distribute, you have 1/4 x. 1/4 times 4 is 1 minus 1. Then we will have f of x equal to 1/4 x minus 1 plus 2. So the final form will be f of x equal to 1/4 x plus 1. This will be the equation of the tangent line. Okay, that is for number 2. Now for number 3, show that the tangent line to this function y equal to 3x squared minus 12x plus 1 at point 2, negative 11 is horizontal. So how are we going to show this one? Take note that the slope of a horizontal line is equal to 0. Okay, the slope of a horizontal line is equal to 0. So therefore, para ma-show natin ito, we must show that the value of the slope of the tangent line is equal to 0. So si m sub TL lang yung isosolve natin. Okay? Since the values of x sub o and y sub o are already given, then madali na lang isolve si m sub TL. So solving for m sub TL, we will have the limit of y minus y sub o kasi yung function natin is in terms of y all over x minus x sub o as x approaches x sub o. Now, substituting the values, y is equal to 3x squared minus 12x plus 1. It is here. Minus y sub o is negative 11 all over x minus x sub o is 2 as x approaches 2. Okay? Now, simplifying, we will have 3x squared minus 12x. So there is x there plus 12x. Then plus 1 plus 11 because negative of negative 11 is positive 11. So 1 plus 11 is 12 all over x minus 2 as x approaches 2. Now, if we will try to do direct substitution, the result will be 0 over 0, which is indeterminate again. So if that's the case, we will factor. So the factors of 3x squared minus 12x plus 12 will be 3 times, so this is x minus 2 and x minus 2 all over x minus 2 as x approaches 2. So from that, we have a common factor that is x minus 2. So this will be canceled out. So what's left now is the limit of 3 times x minus 2 as x approaches 2. So we can do direct substitution. That will be 3 times the quantity 2 minus 2, and this is equal to 0. Since we have shown that the slope of the tangent line is equal to 0, then the tangent line is horizontal. Okay? Now, last example. Verify that the tangent line to the line y equal to 2x plus 3 at 1, 5 is the line itself. So the function is 2x plus 3y equal to 2x plus 3. And our point P is x sub 1, 5. X sub o is 1, y sub o is 5. So we will first solve for m sub TL. So our goal, dapat yung tangent line na makukuha natin ay the same with y equal to 2x plus 3 para it is the line itself. Okay? So we will have find m sub TL. So m sub TL is equal to the limit of y minus y sub o all over x minus x sub o as x approaches x sub o. Then substituting the values, y is 2x plus 3. Y sub o is 5 all over x minus x sub o is 1 as x approaches 1. So from that, we will have the limit of 2x, 3 minus 5 is negative 2 all over x minus 1 as x approaches 1. Direct substitution, you will obtain 0 over 0. So we will factor. So the factors of 2x minus 2 are 2 and x minus 1 all over x minus 1 as x approaches 1. So from that, we can cancel out x minus 1. So what's left is the limit of 2 as x approaches 1. And the limit of a constant is the constant itself. So the value of the slope is equal to 2. Next, we will solve for the equation. Dapat ang makuha nating equation ay the same with y equal to 2x plus 3. So we have the formula y minus y sub o equal to m sub TL times the quantity x minus x sub o. So we will have y minus y sub o is 5 equal to m sub TL is 2 times the quantity x minus x sub o is 1. Now, simplifying, we will have y minus 5 equal to, distribute, you have 2x minus 2. So we will have y equal to 2x minus 2 plus 5. And that is y equal to 2x plus 3. So as you can see, the tangent line is just the line itself. Okay, so that's it for our last um, problem. Now, when can we say that the tangent line of a certain function at a given point does not exist? So we have this remark. So these are the reason why wala tayong tangent line na makukuha. First, the function is not continuous at x sub o. So at the given point, discontinuous yung ating function because from the definition itself, dapat yung function natin ay continuous. Okay? So if walang point, wala kang makikitang tangent line kasi wala kang point of tangency na makukuha. Okay? Second is the function has a sharp corner or cusp at P. Okay, this is the reason um this is the instance when the limiting position sa left side and sa right side are not the same. Okay, para mas makita natin ito, let's have this illustration. The first one is a corner. Makikita natin. When we say corner, we have two straight sides. So, meron tayong edge na point P. If cusp naman, so the sides or yung graph sa left at sa right side ng point P, hindi necessary na straight. So, you can have a curve. So, kasi yung cusp, yung point P will be the turning point. So, mag-iiba yung direction ng curve. So, like this one. So, makikita natin dito sa first one, at point P, if you are going to get the limiting position from the left, so kuha ka ng mga secant lines dito. So, connecting this point and point P, the line that you will get ay i-extend lang natin. That will be the secant line. If ipapalapit natin yung point, the same line lang yung makukuha. Mas malapit, so the same pa rin yung line. So, in that case, the limiting position sa left side will be this line. From the right, yun rin yung mangyayari. So, i-extend lang natin yung line that will be the secant line. Mas malapit, the same, the same. So, in that case, yung limiting position will be the same with the line sa right side. So, as you can see, hindi the same. Hindi nag-coincide yung ating mga limiting position. So, from that, there is no tangent line. Another one, dito sa cusp, yung tangent line natin or yung limiting position from the left will most likely look like this one. Just imagine. And sa right side is paganto. So makikita natin hindi ulit nagko-coincide. So therefore, there will be no tangent line. Okay, so those are the reasons why a tangent line will not exist. So dalawa lang. First, discontinuous yung function at that given point. Second, merong sharp corner or cusp at that given point. Okay? So that ends our discussion in illustrating the tangent line to the graph of a function at a given point. Thank you for watching. So is 5. So we will first solve for m sub TL. So our goal, dapat yung tangent line na makukuha natin ay the same with y equal to 2x plus 3 para it is the line itself. Okay? So we will have find m sub TL. So m sub TL is equal to the limit of y minus y sub o all over x minus x sub o as x approaches x sub o. Then substituting the values, y is 2x plus 3, y sub o is 5, all over x minus x sub o is 1, as x approaches 1. So from that, we will have the limit of 2x, 3 minus 5 is negative 2, all over x minus 1 as x approaches 1. Direct substitution, you will obtain 0 over 0. So we will factor. So the factors of 2x minus 2 are 2 and x minus 1. All over x minus 1 as x approaches 1. So from that, we can cancel out x minus 1. So what's left is the limit of 2 as x approaches 1. And the limit of a constant is the constant itself. So the value of the slope is equal to 2. Next, we will solve for the equation. Dapat ang makuha nating equation ay the same with y equal to 2x plus 3. So we have the formula y minus y sub o equal to m sub TL times the quantity x minus x sub o. So we will have y minus y sub o is 5 equal to m sub TL is 2 times the quantity x minus x sub o is 1. Now, simplifying, we will have y minus 5 equal to, distribute, you have 2x minus 2. So we will have y equal to 2x minus 2 plus 5. And that is y equal to 2x plus 3. So as you can see, the tangent line is just the line itself. Okay, so that's it for our last um, problem. Now, when can we say that the tangent line of a certain function at a given point does not exist? So we have this remark. So these are the reason why wala tayong tangent line na makukuha. First, the function is not continuous at x sub o. So at the given point, discontinuous yung ating function because from the definition itself, dapat yung function natin ay continuous. Okay? So if walang point, wala kang makikitang tangent line kasi wala kang point of tangency na makukuha. Okay? Second is the function has a sharp corner or cusp at P. Okay, this is the reason um when the or this is the instance when the limiting position sa left side and sa right side are not the same. Okay, para mas makita natin ito, let's have this illustration. The first one is a corner. Makikita natin. When we say corner, we have two straight sides. So, meron tayong edge na point P. If cusp naman, so the sides or yung graph sa left at sa right side ng point P, hindi necessary na straight. So, you can have a curve. So, kasi yung cusp, yung point P will be the turning point. So, mag-iiba yung direction ng curve. So, like this one. So, makikita natin dito sa first one, at point P, if you are going to get the limiting position from the left, so kuha ka ng mga secant lines dito. So, connecting this point and point P, the line that you will get ay i-extend lang natin. That will be the secant line. If ipapalapit natin yung point, the same line lang yung makukuha. Mas malapit, so the same pa rin yung line. So, in that case, the limiting position sa left side will be this line. From the right, yun rin yung mangyayari. So, i-extend lang natin yung line that will be the secant line. Mas malapit, the same, the same. So, in that case, yung limiting position will be the same with the line sa right side. So, as you can see, hindi the same. Hindi nag-coincide yung ating mga limiting position. So, from that, there is no tangent line. Another one, dito sa cusp, yung tangent line natin or yung limiting position from the left will most likely look like this one. Just imagine. And sa right side is paganto. So makikita natin hindi ulit nagko-coincide. So therefore, there will be no tangent line. Okay, so those are the reasons why a tangent line will not exist. So dalawa lang. First, discontinuous yung function at that given point. Second, merong sharp corner or cusp at that given point. Okay? So that ends our discussion in illustrating the tangent line to the graph of a function at a given point. Thank you for watching.